Alright, the task is to find the slope of the tangent line. Find the slope of the tangent line tangent line to the function y equals 3 over x divided by 2x minus 5 at x equals 1. Alright, so let's restate the problem to make the procedures explicit. So when you're asked to find the slope of the tangent line, as the same thing as a derivative. Alright, so the slope of the tangent line to y at x equals 1 is equivalent to, or it can be restated as, y prime of 1. Okay, so this entire thing can just be restated as y prime of 1. So all we're doing is finding the derivative of this function and evaluating it at x equals 1. So remember, anytime you're finding the derivative at a point, it's a 2-in-1 problem. The first part is to find the derivative, and then the second part is to evaluate the derivative at the specified x value. So you're going to evaluate y prime of 1. Okay, so don't forget you do your calculus first before you do your algebraic evaluation. Alright, so let's go ahead and take a look at the first part. Part 1, we're to find y prime of x. So if you take a look at the function that we're dealing with, we have the quotient of two linear functions, 3 minus x and 2x minus 5. Now, if you think about the steps that we need to use to apply the quotient rule, because we have a quotient here. Quotient just means divide. Okay? So since we're using the quotient rule, the first step is, can we rewrite this so that we can avoid using the quotient rule? So this problem cannot be rewritten to avoid using the quotient rule, so we have to use the quotient rule. Alright? So step 2, the numerator you call u and the denominator you call v. Okay? The numerator is always u, the denominator is v. Now we are going to apply the quotient rule to the labels that we just used. So u over v prime is equal to vu prime minus uv prime all over v square. Okay? So you can express the quotient rule using low and high. It's just a mnemonic device to help you remember. So the numerator is basically the high, and then the denominator is called the low. So if you want to find the derivative of high over low, so high over low prime, the way that it can be written is you say it as low. Remember, always start with low. Okay, low d, the derivative of high, low d high minus high d low. High d low means the numerator times the derivative d of the denominator, d low. Okay, so low d high minus high d low all over low low, or low square, or square of what's below. Okay, so all over the square of what's below, all over the square of what's below. Alright, apply the quotient rule to this problem right here. So if we apply the quotient rule, we're going to have y prime is going to be v is the denominator, so v is 2x minus 5, that's low, times the derivative of the numerator, 3 minus x prime. Alright, that's low d high minus high d low. High is 3 minus x, or u. V prime, or the low, is going to be 2x minus 5 prime. And then all over the denominator square. Okay? All over v square, or you can call it low. Low times low. Alright, so the denominator is 2x minus 5 square. If we apply our differentiation rules here, we're going to have y prime is equal to the quantity 2x minus 5. Now there's a negative 1 here. Put that in green so you can see. And then when you differentiate 3 minus x, the derivative is going to be negative 1. So this is 0 minus 1 minus 3 minus x. When you differentiate 2x minus 5, the derivative of 2x minus 5, derivative of 2x is just 2. Derivative of 5 is 0. Okay, so that's the derivative of the numerator. And then in the denominator, we just have the quantity 2x minus 5 square. Okay, let's go ahead and refine the result that we have. Make it look pretty. We're going to have y prime. This. So we have y prime is equal to, this is 2x minus 5 times negative 1, which is negative 2x plus 5 minus parenthesis 6 minus 2x. This entire thing divided by the quantity 2x minus 5 square. Simplify further. Y prime is negative 2x plus 5. Now you want to be careful here to avoid making a mistake. So if you have a minus here, don't forget to distribute this negative sign to both terms in the parentheses. Alright, so you are going to have negative 6 plus. This is a mistake most students make. They forget to distribute the minus to the second term. Negative 6 plus 2x. This entire story divided by what? Quantity 2x minus 5 square. Alright, we can simplify further. If we simplify further, the derivative is going to be minus 2x plus 2x cancel out. So it's, if you combine negative 6 and 5, you have negative 1 over 2x minus 5 quantity square. Okay, so the problem asks us to find the slope of the tangent line. We're done with part 1, which is to find the derivative. Now we want to evaluate at y equals 1, which is part 2. Okay, the part 2 step is not calculus, it's just algebra. So for part 2, we want to evaluate the derivative at a specific point, the slope of the tangent line at a specific point, and the point that we're looking for is 1. Okay, so we know that y prime is negative 1 over 2x minus 5 quantity square. So that follows that y prime of 1. How are we going to do this? So we plug in 1 into x and then use order of operations to simplify. So we have 2 times 1 minus 5 square. So this is going to be negative 1 over 2 minus 5 square, which is negative 1 over 3 square, which is negative 3 square. And then when you square a negative number, you get positive, so negative 1 over 9. Okay? So let's go ahead and restate the question in answer format. So the slope of the tangent line, the slope of the tangent line to y at x equals 1 is negative 1 over 9. That, ladies and gentlemen, is your final result.